Okay, so everyone, today I'll be doing the 4.1 quiz about derivatives or differentiation, whatever. First, I'm gonna start, or before anything. First, I have a video explaining derivatives for an hour. I solved so many questions, they're all IGCSE questions. Um, it's very useful if you don't know derivatives or you're studying the IG. Okay, first, before I properly solve the questions, I'm gonna explain what the derivative is. So a derivative can be expressed with dy over dx, or y prime, or d by dx, or f prime of x. Okay, these are all different ways that a derivative can be expressed. Now, a derivative is called, it is a rate of change. All of this can be used to express a rate of change. Okay, so which is why when you have a straight line, when you have a linear line, y equals ax plus b, which I will get into later because it is very important, especially in the first two questions. Uh, the derivative of this, so dy by dx, is gonna be the slope, which is a. That's it. The slope is, again, the rate of change is a slope or gradient. Okay, this is what the derivative is. It's a rate of change, and in curves or in graphs, it is the slope or the gradient at a particular point. Okay, that's all you need to know. Now, there are uh, different ways to derive depending on what you have. However, what we took is simply if you have a curve or yeah, that's a curve. Y equals to a x to the power of n, dy by dx is going to equal to, take the exponent down, so a times n, x, n minus 1. That's, let me explain it with an example. So y equals to, let's say we have 5x squared minus 4x. Okay, dy by dx will equal to, take the exponent down for 5x squared, 10. 2 minus 1 is 1. You don't write the 1 in exponents, خلاص. Minus. This is raised to the power of 1, right? We don't write them, but it is. 1 times 4 is 4. Now, x to the power of 1 minus 1 is going to be x to the power of 0. And you know, anything to the power of 0, so n to the power of 0 is just going to equal to 1. So this is actually going to be 4 times 1. Because again, you know, 4 times 1 is just 4, so you don't write this down. That's it. And this is a derivative. Basically, you just apply this to larger numbers, as we will be doing in the questions that are going to see now. Okay, so the equation of the tangent to the curve y equals 6x squared minus 2x minus 3. At some point a is y equals ax plus b. Now, I want to expand on this. Okay, where a and b are closest to be determined. I want to expand on this because this is very important and a lot of people forgot it. Y equals ax plus b or y equals mx plus b. They're both the same. Anything x plus b or plus c or whatever. There's many different ways to express this line. This is a linear line, right? A or m in any case is our gradient. Gradient, or you took it as slope. Okay, b is our y-intercept. And what is our y-intercept? Our y-intercept is, the definition of a y-intercept is a point on the graph where the x value is 0 and it's at some point y. So if you were to graph it, let's graph this linear line here, any line. This is the line, for example. This here is our y-intercept. Again, x is 0. It is at some point y. We don't know the y coordinate. Here, this is also called the x-intercept. Like we have a y-intercept, we have the x-intercept. Or also in quadratics and like cubics or any numbers greater than, or any curves greater than linear curves, basically. They're called roots. You will see this later. This is at x, some point x, with a y value of 0. Okay, just a little recap about grade 7, because this is grade 7 math. The tangent is parallel. This is very important. The tangent is parallel to the line y equals 10x minus 3. Now, if a tangent is if a line is parallel to another line, right? So let's say we have these two lines. Say they're parallel. They don't look parallel, but imagine they are parallel. Okay, let me just erase it to more accurate. Like this. Say they're parallel. They have the same slope because again they're changing at the same rate. They will never meet, right? That means they're going at the same speed. Basically, think about it as like motion. If they're going at the same speed and they have a difference like in distances, here let's say this one's moving at 5 meters per second, See, this one's also moving at 5 meters per second. This will never catch up to this, right? And you just, think about it like that. They have the same rate of change, same speed, for example. However, they have different y-intercepts. As you can see here, this has a y-intercept greater than this one. So they have the same a or the same m, different b's. So this b will be, for example, b1, and then the other one will be ax plus b2. They will have two different b's. Okay, this is what the tangent means. Now, they might ask you for perpendicular lines. A perpendicular line, I don't know if they will at the exam. They didn't ask it in the quiz, but yani it's extra recap in case they do. Right? Perpendicular line. So let's say you have this line here. Okay, let's say you have this line here. The line perpendicular is, let's say, this one. We graph it like this. Okay, so it's obviously going to make 90 degrees, but that's all what we care about. If this line has the line that's going this way, or both of them, doesn't matter, has the line ax plus b, the a of this one, so y equals to the slope or the gradient is going to be the negative opposite. So it's going to be negative 1 over a. Negative 1 over ax plus, not the same b. Keep in mind, they're going to have the different b's. Look, this one meets at this line here. This is the x-intercept meets at the origin. This one may be like negative 1. I don't know. A different b. They have, like parallel, they have the same properties as parallel in terms of the graph, except for the fact that the m, or the gradient or the slope, is the negative reciprocal of the other one. That's it. That's all I want you to know. This it might be a little confusing. You don't need it. They didn't ask it. Just in case they do ask it in the exam. Yani you never know. Okay. The tangent is parallel to the line y equals 10x minus 3. What's the value of b? Now, first we derive dy by dx 12x minus 2. Okay, a constant always differentiates to 0. Now, this is our gradient, our slope. Remember, this is slope. Our slope in the line that the tangent is parallel to is 10. Now, again, we said they have the same tangent. Sorry, not the same tangent. They have the same slope or the same gradient. So 12x minus 2 is going to be equal to 10. And if you were to make the line, they wanted the form y equals ax plus b, a is going to be 10. We said why? Because they have the same gradient. They have the same slope, the same a. So straight away, we have this so far. This is our curve. This is our line. We don't know b yet, so we don't have the full equation. B is the value they want us to find. Now, that's it. Simple. Take this to the other side. 12x equals to 12. Because you added, you took away this to the other side, you flipped the sign. 12 plus 2, 10 plus 2 is going to be 12. Divide by 12 on both sides. X equals to 1. So, at point A, this is at point A, by the way, because remember, it says at some point A, the tangent is parallel. So A has the coordinate points of 1 and y. We need to find y, right? How do we find y? Very simple. We plug in y, we plug in the x value here, this one, at the original equation, the original curve. So y equals to 6x squared, x is 1 again, so 1 squared minus 2x, 2 times 1 minus 3. This is going to give me 6 minus 2 minus 3, or 6 minus 5, which is going to give me 1. So our coordinate point A is actually 1, comma 1. Again, this is x here, and this is y here. Now that we have this, okay, we can go about 2 different ways. We can, first of all, use y minus y naught, or y0, equals to m minus or m into x minus x naught. This is known as the slope intercept form. I'll expand on it a bit later. Or we can keep going with y equals mx plus b and substitute accordingly. I'm going to solve with both ways. First, I'm going to start with this one. Y minus y naught is equal to m minus m into x minus x naught. Now, what do you fill out here? Because look, there's a lot of variables, and it's going to be confusing. What is there to solve here? These y's are very weird. There we go. Okay. You substitute your m, you substitute your gradient, and you substitute any values with a naught or a 0. Okay. So y, you don't substitute anything here because it's just y, minus y naught, which is 1, equals to Our gradient was 10. Remember, same in a parallel line, same gradient. So 10 x, you don't substitute anything in this x, minus x naught. X naught is going to be 1 because x is the point here. Okay, so you can see we got the 1 from here and we got the 1 from here. That's what you substitute in. The notes and the notes you substituted them with their coordinates, and the m you find it. Here we found it. خلاص, that's it. So y minus 1, we're going to expand this 10x minus 10. Take the 1 to the other side. Y equals 2 10x plus or minus 9. Again, because minus 10 plus 1 is minus 9. This is our equation. And they want b. B is minus 9. That's it. Now, you might be asking, why didn't we put 9? Because they said it is in the form y equals ax plus b, right? Plus here. So, what we have it as 10x minus 9 plus b is equal to minus 9. That's it. That's, يعني, if they asked for ax minus b, you just write 9. But they asked for ax plus b. Okay. The equation of the tangent to the curve y equals 4x squared minus 3x at 1, 1 is y equals x plus b. Okay. Same thing, except this time it's much easier because you have your coordinates given. So straight away, I don't know why I did that. dy by dx equals 2, 8x minus 3. Okay. Now we want to find the gradient at this point, right? So we're going to substitute in 1 for the x because we have it at 1. Because again, if it's a straight line, your gradient is a constant. You're always going to have a constant gradient. However, if it's not a straight line, right, you are going to have, for example, let's say it's a quadratic. The tangent at this point is going to be the difference from the tangent at like this point. They have different slopes. So, or different gradients. So that's why we have like a full on dy by dx for it. And this is why if we substitute, like for example, what might be the slope for this one will not be the slope for another point. So even if you change the x by 1, the point at it won't be realistic. يعني مثلا 2 at x equals 2, whatever, 2 comma y. I don't care about this now. The slope at 1 1 is gonna be different than the slope at 2 comma y. Okay, so dy by dx is 8x minus 3 at x equals to 1. 8 times 1 minus 3, this is dy by dx, equals to 5. Okay, so it is y equals 5x plus b. This is what we have so far. Okay, now we can again go about it the same way. Y minus y naught equals to m into x minus x naught, or y equals to mx plus b, and we just use substitution. I don't think I used the substitution method last question, so I will do both this time. Okay, so y minus, you substitute in your notes. Y is 1, and x is 1. Remember, it's x comma y. M is 5, 5. X minus x naught is 1. Okay, so y minus 1 is equal to 5x minus 5. Y equals to 5x plus or minus 4, sorry. 5x minus 4. And this is the answer. X is going to be minus 4. The same reason why we put minus 4 is the same reason why we put minus 9 in the other question. Now, I'm going to use y equals mx plus b for this one. Or ax plus b, doesn't really matter. Y equals mx plus b. Let me erase this one because I don't need it. We have so far y equals to 5x plus b. We have our m. And we have our coordinates. So what we're going to do, we're going to substitute 1 and 1 for the x and the y. So our y is 1, so 1 equals 2. 5, x is 1, 5 times 1 plus b. Right, we don't know b yet. So 1 equals 2, 5 plus b, take 1 to the other side, take with the 5 to the other side, b equals to 4. Or minus 4, sorry, minus 4. That's it. Question 3. So this is way easier than any other one. dy by dx is equal to 12x cubed plus 11. Okay, at the intersection with the y-axis. So when they say this intersection with the y-axis, why does it keep doing that? Intersection with the y-axis. This is the y-intercept. Think about it, right? I'm gonna graph it in the cubic way. I don't know if this is gonna be. It's not accurate, obviously. Say it's like this. This is the intersection, right? Look where it intersects. It is gonna be the y-intercept. Okay, and this here, this point here is gonna be our root, and this is gonna be our second root, and this is gonna be our third root. Now, why am I telling you this? You'll need it for later. Uh, anything that is not linear, right? And it intersects with the x-axis on like a non-linear curve, we call it a root. Okay, y-intercept. So this means that x is equal to 0, right? And they want the slope. They don't want the equation. They just want the slope. So we're not going to use anything else. We're only going to use dy by dx. So at x equals to 0, dy by dx equals to 12 0 times 0 cubed plus 11. This cancels because anything multiplied by 0 is 0. So equals to 11. And again, dy by dx is our slope. So it is 11. And that's our answer. If they wanted to expand that, let's say they wanted the full thing. So y equals 11x. They wanted the full equation of the tangent. We're going to look at that like this. We're going to substitute in our values, which we don't have. So what we're going to do is y equals to 3 times 0 to the power of 4 plus 11 times 0 minus 1. Again, point of intersection with the y-axis is y-intercept. So at x equals to 0. So I'm just substituting x equals to 0 for these points. So y equals 2. This is going to be 0. So 0 plus this is going to be 0 minus 1. Y is going to be minus 1. Right? So our point is actually 0 minus 1. Okay? Now we're going to substitute in this point. Minus 1 equals 2. Y equals mx plus b. Again, we have our m. We're just taking whatever we have here. Minus 1 is equal to, which is our y. 11 times 0 plus b. So minus 1 is equal to, this cancels. So 11 is equal to positive b. So b is equal to minus 1. Khas, this is our answer. So the actual equation of our tangent is y equals 11x minus 1. And this is our answer. But we don't need it. We only wanted the slope. Khas, no need. The curve that represents the graph of y equals x squared minus 2x minus 8 crosses the x-axis, so it is our roots. And by the way, roots, I don't mean like this. This is not what they want. One point has a negative abscissa and one point has a negative. Wait, what? One point has a positive abscissa and one has a negative abscissa. What is the slope of the tangent where the curve crosses the x-axis at the point with the negative abscissa? Okay. Now, to find our roots, right, we're gonna do dy by dx is equal to 2x minus 2. Okay. Now, whenever you have or sorry, this is the extreme points. Never mind, I'm mixing them up. Whenever you have this, right? Just give me a second. Let me pause the recording. Okay, so my bad. Whenever you have this, right, and they want the roots, again, there's multiple ways to solve. You can complete the square, or you can factor, or you can use the quadratic formula. Now, the easiest thing to do, arguably, would be on your if your calculator has the not the equation solver, the equation mode. So let me go to open it. So if your calculator, I have both of them, but I will use this one. Just give it a second. So if your calculator is one of these ones, the properly good ones. If it's FX570 or FX991ES plus, or if it's the newer ones, the Class Wiz, and it's the blue and white one, you know which one I'm talking about. It has this equation setting. So you press mode for this one at least. The other one you should not use it. You press 5 for equation. Okay. You press 3 for ax squared, whatever. You substitute in the values. Now, you have ax squared plus bx plus c. We're going to substitute on our points like this. It's going to be 1x squared minus 2x minus 8. So a is 1, b is minus 2, and c is minus 8. So this is what we're going to put. 1, that's 11. 1 minus 2 minus 8. you solve it, it finds the roots. So one, our x, our first one, our positive abscissa is 4, and our second one is, you press equal again, -2. Okay, now I'm not gonna rely on this, right? Because some of you don't have this calculator. What I will do though, I will factor it, and I'll factor it. You know, there's many different ways to factor, so everyone factors with a different way. The way I do is the AC method. So first, what I do, I multiply ny equals ax squared plus bx plus c. I multiply a times c, and then whatever value this gives me, I split the b term into the value that will equal that. Here, let me explain it. So y equals 2. This is 1, this is -8. So AC is equal to 1 times -8, which gives me -8. So I need to split this equation so that it equals -8, right? Or sorry, I need to split the b term only so that it equals to -8, and it is that it splits up into like a normal way. So what are my factors of 8? We have 1 and 8, 4 and 2. That's it, right? Or let me flip it, actually 2 and 4. So 1 comma 8, 2 comma 4, like this. Okay, so this and this will give me 8, right? I just need to flip 1 so that it is gonna give me -8. Now if the middle term is negative, the bigger one's gonna be negative. So -4x plus 2x minus 8. Okay, so now I continue by just taking them to the other side. So x squared minus 4x plus 2x minus 8. Okay, you guys took this method. There were many ways of factoring. They were all in the book. I just used the one that's more convenient for me. I factored out this one, x. X is the common factor. So x minus 4 plus 2 is the common factor here. So 2x minus 4. Now they have to both have the same, the same number inside the bracket. So when this is the case, it's going to be x plus 2, x minus 4, and this is my factor. Now keep in mind, don't factor like this if you don't understand it, because there are different cases to it, and this is just the way I understand it. Yani this is my preferred way of factoring. However, some people don't get it. So now when it's roots, when it's crossing the x-axis, y is going to be 0. So x plus 2, x minus 4 is going to equal to 0. Now you know that this now you can use the zero product principle from it, which basically states that this part equals to 0 and this part equals to 0. So x plus 2 equals to 0, x equals to -2, x minus 4 equals to 0, x is going to equal to 4. Now this is where I'm going to stop. Now they want the one with the negative abscissa. I'm not going to use this. This x equals to 4, I'm not going to use that at all, because I don't need it. They want the negative abscissa. So we only are going to use x equals to 2 or -2. So now we derive dy by dx is equal to 2x minus 2. Okay. They want the slope of the tangent only, so I'm just going to substitute -2 into dy by dx. dy by dx is equal to 2 into -2 minus 2, which is -4 minus 2, which is -6. And this is our answer. Okay, question 5. How many minutes am I in so far? 23. Oof, we're barely done. What is the gradient? Okay, this one I am going to teach you an optional way you do not need to know at all, only if you don't understand how to derive it with fractions. Okay, so don't do it like this. Wait, let me properly expand it first. So 2x minus 1, x plus 7. Okay, first and foremost, you can find the derivative on your calculator. Your calculator can derive for you. So if you have the x values, it won't find like the equation of the derivative. So you have this 2x minus 1 and x plus 7. I'm not going to show you how to do it because you should know how to do it by now on the calculator. If you don't, actually, I don't have it open. I'm not going to open it again. So let's expand all of this. Just give me a second. Let me pause. Okay, so my bad. I had to do something. What we're going to do first, we're going to expand this, right? This expands to 2 x squared plus 13x minus 7. Just I just expanded this. You know how to expand? I just did it mentally now, so it's very easy. Now, what we're actually going to do here, we are going to factor out 1 over 3. So y equals to 1 over 3 times 2x squared plus 13x minus 7. Okay, now you might be asking me, how did we factor out 1 over 3? It doesn't make sense. Because if you think about it, this is actually just equal to 2x squared over 3 plus 13x over 3 plus minus 7x minus 7 over 3. So minus 7x minus 7 over 3. So you can factor out 1 over 3 from all of this. Okay, now what we're going to do, very simply, we are going to differentiate each term by itself. Okay, so dy by dx is going to equal to, this is dy by dy. Okay, that's a new one. We're going to differentiate what's inside. This is a multiplicative constant, which means we don't do anything to it. Just keep this in mind. So it's actually going to be 1 over 3 times 4x plus 13. This is our derivative. Okay, now what we're going to do, we're going to substitute it at, we're going to substitute x equals to negative 1 for it. So dy at x equals to negative 1, dy by dx is going to equal to 1 over 3 times 4 times negative 1 plus 13, which equals to, sorry, I added the other bracket, I need to do that, plus 13. This equals to, this is on a calculator. Where is my calculator? Speaking of, it is right here. Now this doesn't need a calculator, but it makes my life much easier because I don't have to figure out what 1 over 3 is. 1 over 3 times 4 into negative 1 plus 13, which gives me dy by dx, this is gradient, to be 3. Now, there is another way, and this is completely optional, so skip it. Go ahead. I would actually prefer you don't know it, but if you don't understand what I just did, you don't understand the multiplicative constant, which is quite annoying, I understand. What you can do is there's something called the quotient rule, which is dy by dx, or d by dx, that's even more accurately, d by dx over the derivative of u over v is going to be equal to, first, I start with the bottom. I always start with the bottom when I use the quotient rule. V squared. Just keep this in mind. Now we have V squared here because the order is very important. Keep in mind. V squared. So I'm just going to put V up. This is why I start with the bottom, to make it easier to know where I start up. V multiplied by u prime, or the derivative of u. So let me write it in a more accurate way. So it's going to be V times du over dx, or du by dx, minus u dv by dx, or again, to make it much simpler, sorry, vu prime minus uv prime. That's it. This is my quotient rule. So it's pretty easy in concept. I'm okay. Let's apply it. It's fine. D by dx is equal to of all over 3 2x minus 1 into x plus 7. Okay, now what I'm gonna do here is simply what was this? This was 2x squared plus 14x minus 7, right? We're gonna expand this to make it easy. 2x squared plus 14, or plus 13x, sorry, plus 13x minus 7 over 3. Okay, now remember the rule. I'm gonna keep it up here so you guys don't forget it. U over v equals to v squared v du by dx minus u dv by dx. Okay, u is this. U is to act the long quadratic, and v is 3. So first, start with the bottom. Or even better, start with the deriving. So du by dx, basically, which means the derivative of u. U again is 2x squared plus 13x minus 7. So it's going to be 4x plus 13. This is the derivative. And dv by dx, which is basically the derivative of v, is 0. Because 3 is a constant, it always differentiates to 0. Wait. Yeah, okay, that's perfect. Now, this is going to equal 2. Let's start by working it out. So, V is 3, right? Or you know, as I said, it's always better to start from the bottom. So, over 3 squared, which is 9. V is 3. Du by dx. What is du by dx? 4x plus 13. Minus u, which is this very long quadratic, which is uh, 2x squared plus 13x minus 7, all in brackets, multiplied by dv by dx, which is 0, which is actually why this is going to be very easy. Now, we're going to expand first at the top. So first of all, everything over 9, this is going to be 12x plus 13 times 3, which is 39. Minus this all, it's going to be multiplied by 0, right? So this always just cancels out. So this is our actual derivative. Now, you can keep it like this. So 12x, 12 times -1 plus 39 over 9 still gives you 3. However, you can factor it out. You can factor 3 out because this is all multiplicative by 3. So 4x plus 13 over 9. Basically, take it to the original form. Divide this by 3 here, divide this by 3. So it's going to be 4x plus 13 over 3. And this is how to differentiate using the using the quotient rule. Now, this might seem very unnecessary for questions like these. Okay, and I do agree. However, in grade 11, you're going to take very long equations that are going to be difficult to derive. Or not very long, but, you know, much easier to derive using the quotient rule than the product rule. Or the, sorry, what was it? The normal way. Speaking of the product rule, that's another rule you need to know. Or not need to know at all. Don't know it. You don't need it. But, يعني, let's explain it. D by dx, I'm not going to go into it because it's very self-explanatory and it's much easier than the quotient rule. U times v is going to be equal to u, or sorry, doesn't really matter, v u prime plus u v prime. That's pretty much يعني easy. Now, you might ask me, what's the point of this? يعني مثلا if I have 2 here, 2 for v and 3 for v. Okay, that's very useless. I know that's just going to be the derivative of 6. However, we can apply it to this here, this top part, 2x minus 1, x plus 7. Let's let 2x minus 1 to be u and x plus 7 to be v. You can derive each and then add and then apply the rule or whatever, or you can just do this, which, you know, whichever suits you best. خلص I'm not gonna go into detail because I will actually keep solving with them. يعني if you actually want to know about it, I will keep solving with them. But you know, in case you don't need to know. Speaking of, this is a pretty good application of the product rule. So what's the gradient of y equals to negative 2x to negative 3x squared minus 4x at x equal 1? So first, let's expand this. I'm gonna solve using the normal way. Expand this is gonna be 6x cubed minus or plus 8x squared. Okay, now dy by dx is equal to 18. This is not 24. 18x squared plus 16x. Okay, at x equals to negative 1, 18 negative 1 squared plus 16 into negative 1, which is going to be equal to 18 times 1, since any number squared is going to be positive, minus 16. This is going to equal 2. That's it. Now, there's also the product rule, which I'm going to show here. You don't need it, but again, you know, skip if you understand the first part or you don't want to know, خلاص, it's fine. I'm just saying it's going to make your life easier in grade 11. So I'm just going to start by writing it down. VU prime plus UV prime. Okay. So d by dx is equal to what is u? U is negative 2. And then v is negative 3x squared minus 4x. Okay, so let's start with v. V is, as we know, negative 2x. Or no, u is, doesn't really matter because it's additive anyway. U is negative 2x. So u prime, or the derivative of u du by dx, is going to be equal to negative 2. Okay, v is negative 3x squared minus 4x. So v prime is going to equal to negative 6x, sorry, negative 6x minus 4. Okay, so now that we have this, again, it is v times u prime. So what is v? V is negative 3x squared minus 4x times u prime, which is negative 2, plus u times v prime. U is negative 2x, plus v prime is, or sorry, into negative 6x minus 4. Now, let me actually take this to a separate page. No, it's getting too long to solve here. There you have all of this. We're going to just expand. So, negative 2 times the negative 3x. So, this is going to be 6x squared. This is going to be plus 8x. Plus negative 2x times negative 6 is going to be negative or positive 12x squared. And negative 2 times negative 4 is positive 8. Okay. Yes, is everything right? In a positive 8x here. This is negative 2x, right? Let's just be sure. Negative 2x, yes. Okay. So 6x squared plus 12x squared is going to give me 18x squared. 8x plus 8x is going to be 16x. And this is our final answer. D by dx of whatever this was equals to this number. And as you can see, we got the original answer, the same original answer. Again, totally unnecessary for our grade, but it will be necessary later. So keep them in mind. If you want to use them in the exam, your choice. Don't. أهلا وسهلا. Okay, this is actually a similar concept to the other question we did. So, what is the gradient of y equals 6x to the power 4 plus 24x cubed over 3x squared at x equals to 3? Okay, so y equals to, we're just going to rewrite everything down. So 6x to the power of 4 plus 24x cubed over 3x squared. What's this, question 7, by the way? Yes, it is. Okay, perfect. So now that we have this, right, we are gonna simply this is way easier, by the way. We're gonna divide each of this by this. So you know how to divide already. 6x to the power of 4 over 3x squared. Because remember, let's split up the fraction to make it easier on everyone. 3x squared plus 24x cubed over 3x squared. Okay, divide everything. So 6 over 3, 2. X to the power 4 over x to the power 2. 4 minus 2, you know the a to the n, or a, whatever, that's n to the a and n to the b is equal to n a minus b. Same rule. X is n in this case, and a is 4, b is 2. So 4 minus 2 is 2, plus 24 over 3 is 8, x, that's it. Okay, so now dy by dx is equal to 6, sorry, 16, 4x plus 8. This is my final derivative. So at x equals to 3, dy by dx is going to equal to 4 times 3 plus 8 equal to 18, or 12 plus 8 is going to equal to 20. That's my final answer. Perfect. Okay. Now, question 8. What is the gradient of y equals x to the power of 6 over 3? Okay, this came in the AMS quiz many times. Well, a lot of people don't understand it, so I will explain it in detail. Now, first, let's start by rewriting everything. Okay, now, let's derive this first again. We're just going to derive our into individual components. So d by dx is going to equal to 6x to the power of 5 over 3. And then this one, d by dx. By the way, what's the difference between dy by dx and d by dx? Now, at our level, you can use both. However, if you want to differentiate individual components, use d by dx. If you want to differentiate the overall thing to show the overall derivative, it's going to be dy by dx. However, yeah, I'm going to make it easier on everyone, and I'm going to differentiate each of this into its individual components. So I'll use d by dx for both, then I'll combine it into the final dy by dx equal to, this is going to be 24x to the power of 7 over 4. Okay, now this can be simplified, right? This is going to 6 over 3. 6 divided by 3, divide this 1, 2, 2x to the power of 5. Okay, 24 over 4, 4, 6. Okay, minus 6x to the power of 7. So this is dy by dx. And this is our final derivative. Now, what we're going to do now, very easy. We're going to do x equals to -1. So dy by dx is going to equal to 2 into -1 to the power of 5 minus 6 into -1 to the power of 7. Okay, now you can do this on a calculator, and يعني if you have the chance, why not? See هلا حتصير -2 minus negative or minus 6. So this becomes, I don't think, yeah, it is right, never mind. So this becomes, because again, this is going to be -6. This is no longer going to be 6. This is going to be minus 6 into -1 if you think about it. Right? So this is going to give me minus 6. So this becomes -2 plus 6, which gives me 4. And 4 is my final answer. Okay, question 9. What is the gradient of y equals 4x plus 3x squared at x equals to 4? This is very easy. Dy by dx is going to equal to, let's rewrite this. I don't like it like this. We're gonna flip the order into standard form. So 3x squared plus 4x. Same thing. That's the same fraction. It's the same equation. I just changed the numbers to make it easier on myself to derive. So dy by dx is going to be 6x plus 4. Now, at x equals to 4, dy by dx equals to 6 times 4 plus 4, which gives me 24 plus 4, which equals to 28. And this is my final answer. Okay, question 10. What is the gradient of y equals 3x to the power of 4 plus 2x squared minus 4x? Okay, dy by dx, always, in this, just do dy by dx, 12x cubed plus 4x minus 4 at x equals to -1. This is going to be 12 into -1 cubed plus 4 into -1 minus 4. So this is going to be -12 minus 4 or -16 minus 4, which is -20. يعني I'm just take cost -20. Okay, question 11. Very easy. Dy by dx straight away, it's going to be 12x squared at x equals to -2. I'm going to stop writing that. Dy by dx equal to, so this is going to be 12 times 4, because again, any number squared is going to equal to a positive number. 12 times 4 is 48, and 48 is my final answer. I'm just going to speed run through these very easy questions, unless it's a hard question, and I'm not going to think about it. By the way, you should be able to do this mentally. This might seem very difficult, but it's actually very easy. Dy by dx is going to equal to 12x to the power of 11. Okay? Right? We just derived. Now, it is at x equals to 1. Okay? So, at x equals to 1 dy by dx is going to equal to 12 times 1 to the power of 11. What is 1 to the power of anything? To the power of مثلا 900. It's going to equal to 1. Anything. 1 to the power of anything is 1. So it's going to be 12 times 1. It's going to equal to 12. And don't let this confuse you. But it shouldn't. And unless it puts x equals to 3. Okay, that's when you actually need it. Okay, this is annoying. Not annoying in the sense that it's annoying. It's annoying in the sense that it's not very nice. Okay, so first of all, we can immediately cross one out. Why? Because the gradient at x equals to 0, x equals to 0 is the y-intercept. As you can see here, we're going to take this in the next section. I will explain this in the next section further. This is a stationary point. The derivative is flat. It's just 0. So the gradient of the curve is not going to be... Why can't I erase? So here there is basically no derivative. So this is wrong. Right? They gave us the derivatives anyway. There is no line. There is no tangent. There is nothing. The gradient isn't there. Okay, the gradient of the curve at x equals to 2 is equal to 3. Let's, let's solve this. So here, this is the point. We're going to take the points of the tangent they gave us. This is going to be 2, or sorry, -1. Here we take the point -1, and this is 2, -1 and 2. Okay, here this is the point -2, -2 and -1. So let me rewrite it here in a better way. -2 and here -1. Okay, so again, now it's a straight line. So all we can do is the slope, or m, is equal to y2 minus y1 over x2 minus x1. M is equal to y2. We're going to take this as y2 x2. Doesn't matter which one you take. This is going to be y1 x1. Okay, y2 is 2. 2 minus 1. And then x2 is -1 minus -2. Do this on a calculator, you get, or you don't even need to do it on a calculator. 2 plus 1 is 3. -1 plus 2 is going to be 1. Again, because 2 negatives make a positive, and 2 negatives make a positive. So this is going to be 2 plus 1 and -1 plus 2, which is 3 over 1, which equals to 3. Okay, so the gradient at x equals to -2. Let me rewrite it at a better way. X equals to -2 equals to 3. Okay, now let's find the other one. So this is going to be here. This is 3 and this is 2. So it's going to be 2 and 2 comma 3. And then our other point is very easy, 1 comma 0. This is our second point. Okay, now very easy. 3 minus 0, y2 minus y1 over x2 minus x1. 3 minus 0, 2 minus 1. It's going to be 3 over 1, which equals to 3. So the gradient at x equals to 2 is also equal to 3. So here we have this correct. And the gradient of the curve at x equals to -2 is equal to the gradient at x equals to 2, which is also correct, because here it's equal to 3, it's equal to 3. That's correct. And these are our 2 correct options. Okay. I believe there's 2 more questions. No, 3 more questions. Okay, that's fine. No, I missed this. I definitely skipped a question. Oh, no, I didn't. Okay, perfect. Last question 14. What is the gradient of the curve at the point of abscissa 2? Okay, first of all, we can take this point, because again, any point of the tangent is gonna, of a point, is the point of that is gonna belong to the tangent. You know what I mean? I can't really explain it. يعني 2 comma 0, and then we're just gonna take any other point with a whole number. Here, this is gonna be 1 comma 4. Okay, now first of all, we know that the tangent is going, the slope is going downwards, because it started, the x value was 1 at 1, at x equals to 1, y was equal to 4, right? When at x equals to 2, the y value changed to 0. right? So we know that this is sloping downwards. So our tangent, our gradient, our rate of change should be negative, first of all. So that's just a, يعني a method of verification. Okay, so x2, y2, x1, y1. Let's just start by labeling our points. y2 minus y1, 4 minus 0 over 1 minus 2. This gives me 4 over minus 1, which is going to be negative 4. And this is our gradient. Because again, it's a straight line. The m of a straight line is equal to y2 minus y1 over x2 minus x1. Any very easy work. Everyone should know this. Question 15. What is the gradient of the curve at A? Same concept. A is this point. Okay. So the tangent of A is this tangent here. We can take this point first of all. It is negative 0, negative 3. That's one of the points. And we can take this point here, negative 2, 0. Okay, so y2 minus y1 over x2 minus x1. y2 is, let's say this is, doesn't really matter again. This is x2, y2, x1, y1. So 0 minus minus 3 over, so 0 minus minus 3 minus 2 minus 0. So it's going to equal to 3 over 2, sorry, 3 over negative 2, which is equal to negative 3 over 2. خلص, that's it. So our tangent should be negative 3 over 2 or 1.5. Negative 3 over 2, that's it. Negative 1.5, sorry. Uh, Same thing. Very, very easy. So dy by dx is equal to 3x squared plus 8x. Right? Now, again, it's very optional. You don't need to do this, but you can factor out x, right? It makes your life, in my opinion, easier. 3x plus 8. I'm not going to use this. I'm not going to overcomplicate things. You don't need this. I'm not going to use it. It's fine. I will only factor out numbers with very large values. So we have this at x equals to 2. They want it in the form y equals mx plus b. So at x equals to 2, we have 3, 2 squared plus 8 times 2. This is going to be 3 times 4 plus 16, which is going to equal to 12 plus 16, which equals to 28. So our equation right now is y equals 28x plus b. This is what we know so far. Okay, we don't need this anymore. We're done. We're going to substitute an x equals to 2 to find y. So far our value is 2 comma y. We need to know y, like any other question. Okay, so y equals to 2 cubed plus 4, 2 squared plus 10. Okay, so y equals to 8 plus 16 plus 10. Y equals to uh, 8 plus 16 is 24, 34. That's it. Okay, so now that we know this, we're going to substitute in this point. So 2 comma 34. Okay, now in instances like this, it's much easier to use y minus y0 over equals to mx minus x0. Yani, just to make your life easy. So y minus y naught equals to m x minus x naught. Okay, so y, we keep it substituting for y naught, which is 34 equals to m, which is 28 x minus 2. Okay, so y minus 34 is equal to 28x minus 28 times 2 is, put on calculator, 56. Okay, then you take 34 to the other side, 28x minus 56 plus 34, minus 56 plus 34, minus 22. And this is your final answer. That was the end of the quiz. Yalla. Good luck, guys. Study well.